you all had a good Thanksgiving, and we're in the home stretch. It's a little unusual because usually we only have one day after Thanksgiving, and this time we have a week and a half, but just hang in there. A couple quick announcements. First of all, if you fill out the student evaluations, then you can get an extra 30 points are available. So an extra 30 homework points are available if you complete the student evaluation, which I believe now they call it Tennessee Voice. And what I need is the confirmation page. You can take a screenshot of it, and there's a link on Canvas called SAIS confirmation, so submit it to the SIS confirmation link. On Canvas. So it's one of the, I think it's under the homework assignments that you can find it. Then second announcement, I did post some solutions for homework 8. They're not particularly good as far as the layout, but they show you the flow of information between the PHP scripts, which is I think what gave most of you some issues. And then the third announcement, reminder for the graduate students in the course that you need to demo your project for Elvis by Thursday, November 30th. So it's a deadline you need to be aware of. So we are into JavaScript. The video lecture last Thursday, not Thursday, Tuesday, went over some of the basics of JavaScript and why JavaScript is a more limited language than the ones you've dealt with before. Does anyone remember what makes JavaScript a more limited language and also what makes it safe for executing on your machine? Can't read or write, well, yeah, you can't read or write files. There's a way that modern versions can do it if you give permission, but you typically don't. But the inability to read and write files really limits its applicability for general purpose applications. So it wasn't designed for that anyhow, but it's the first language we've seen that where it truly is hard to accomplish certain tasks in it because you can't read or write files. So as we said last time in the video lecture, the point of JavaScript is to be able to interact with a web page. And today we're going to go into how that interaction takes place via interaction with something called the Document Object Model, or DOM. But before we do that, we need to finish up a discussion of JavaScript's objects, which you were introduced to in the video lecture, but not fully briefed on. So JavaScript is the first language you've seen that is heavily object-oriented this semester. Perl wasn't. PHP has classes, but it's not necessarily your first inclination is to use objects in PHP. But JavaScript's really organized around objects, starting with this DOM object that I'm been talking about. So you really need to know how they work. And the object model, in terms of syntax, is loosely based off the syntax for C++. But as we'll see, the type of model it is fundamentally different. It's something called a prototype instance model as opposed to the class instance model that you're familiar with. But quickly, let's review some of the key points. So if you want to create a new object, you use the new keyword just like you would in C++, and you use the delete keyword to get rid of an object. But unlike C++, you can create anonymous objects with this curly brace syntax. Looks a lot like a hash table in Perl. And essentially that's what it is. So objects in JavaScript are in fact hash tables. So the underlying data structure, just like with Perl and PHP, is a hash table. And if you want to essentially just create a hash table, then this notation will do the trick for you. So that creates an anonymous object. Has no superclass. It's just an anonymous object. And they operate just like dictionaries in terms of the syntax. There's two different ways that you can access the so-called instance variables, which in JavaScript are referred to as properties. So you can use either the dot notation, which is the top highlighted line, or you can use the associative array syntax, which is the squared off brackets. So either way works. And just like PHP and Perl, there is no access control. So everything is public. Again, you're really not, and here sometimes, actually I was going to say you really shouldn't access properties, but in fact sometimes that's exactly what you do, is you access properties rather than changing them through methods. Okay, and then the constructor function. So there is no class keyword in JavaScript. You don't actually create a object with the class. Instead, you simply create a so-called constructor function. So here we're creating a class called account, and we're just defining its constructor function, and we're showing the parameters it takes. There's no overloading allowed. You only get one constructor function. And one way you can tell that it's a constructor function is the this. So that is implied, defined for you by JavaScript. So this is a pointer to the object, or to the allocated object. And then if you want to create a new object, you simply prefix that function with the new keyword, and it treats it as though you're creating an instance of that object. Now, when you do that, it may be a bit hard to, you're thinking, well, how do I add methods? It's very easy. You define a function, then you assign a function name to one of the properties. So I could, let's see, if I wanted to, well, I could have a function foo. Actually, let's make it function getName. And we will have it return this.name. And then here in the function account, we could have said this, and I can name it anything I want, but in this case I will actually say getName equals getName. And that essentially assigns a function pointer to the property, and that's the way that we go about assigning methods to our objects. So in the constructor, we typically are assigning methods to properties. So adding methods to objects, so typically the methods are added in the constructor. I'll say the constructor function. Well, the other thing that might occur to you is with classes, with the class syntax, you typically have a way of saying a superclass. But if you just have a function that creates instances of the class, then how can I specify that something is my superclass? And the way that you do that is with a property called prototype. So you can set the prototype property to point to an instance of another object. And when you do that, effectively that instance of that object becomes your superclass. So it has to be a concrete instance. So here you can see I've created two constructor functions, one for C and one for B. And then I want to, in effect, make C be a superclass for B. And you see the way I do it is by creating a new instance of C. It doesn't work to actually say that b.prototype equals C. So you might think, why can't I just say b.prototype equals C? But that doesn't work. You have to create a new instance of C. The prototype must point, so the prototype must point to an object, not a function. That's why you have to, so this doesn't work, okay? That's incorrect. You have to use instead the syntax that I have right there where I add it to an instance. Or yeah, I create an instance of C, set B's prototype to that. So what happens when you now go and look for a variable like B1 height, then that variable or property is not defined in the object B, then it follows the prototype property, goes to whatever object is pointed to by the prototype property, and if height is defined in that object, it takes the value of that height. If it's not found there, then it follows the prototype for C, and so on. So it's just chasing those prototype links until it finds a definition for height, or if it exhausts that chain, then eventually it would return null. So this type of object model is actually called a prototype instance model. And this is different than what you've seen previously. So what you've seen previously are something called a class instance model. In fact, Perl and PHP both use prototype instance models as well. I just didn't dwell on that fact. So in general, scripting languages use prototype instance, and compiled languages typically use class instance. Okay, so let me first tell you what the difference between prototype instance and class instance is, and then I can explain why scripting languages typically use prototype instance and compiled languages typically use class instance. So what I'm going to do is show the difference between the two. So here we have prototype instance. Here we have a class instance. And there's kind of three big differences. So first of all, the question is, can you dynamically add and delete instance variables? I'm going to do a little abbreviation. So with prototype instance, the answer is yes. With class instance, the answer is no. With class instance, the set of instance variables is static and defined by the class. Whatever the class says are the instance variables, those are the instance variables for the life of the program. Every object or instance you created the class will have the same set of instance variables. However, with the prototype instance model, you're allowed to dynamically add or delete instance variables from both the prototype and from the instance. So earlier, you saw that I had here, I defined height for C and width for B. I'm allowed, after creating B1, to say delete B1 dot width. And that will delete the variable, that instance variable from B1. Width will no longer be defined. You can't do that in a class instance model, but you can in a prototype instance model. Or I could say B1 dot prototype dot width equals 40, and now effectively what I've done is added the width variable to the prototype for B1. So I've added an instance variable now. In effect, what I did with those two statements was remove the width variable from B1 and add it to the prototype for B1. So that's one of the things that I can do, is I can dynamically add and delete instance variables. Now, if I can have instance variables in both the prototype and the instance with the same name. So after saying b1.prototype.width, I could go ahead and now say b1.width equals 80. And for the time being, the width of b1 is 80 because it takes precedence over the width in the prototype. But if I now delete b1.width, b1's width will now become 40 because JavaScript will search up the prototype chain and will find width in the prototype. So even though I deleted the width variable from b1, in some sense it's still part of b1 because I find it now in the so-called superclass or prototype. Okay, so that's one difference. Prototype instance, I can dynamically add or delete instance variables. Second difference is that a prototype / class is an object at runtime. Let me say a mutable. Again, in the prototype instance model, the answer is yes, and in the class instance, the answer is no. So you just saw that I was able to modify the prototype for B1. I added a width variable to it. So actually, it should be pretty clear that it's an object and it's mutable. Whereas with the class instance, it is not an object at runtime. Now in Java, it's an object and you can query it for information, read only, but you're not allowed to go in. Actually, you can also set global variables in classes, but you can't dynamically add or delete instance variables from a class. And I guess that's the big difference. It's not what we call a first class object at runtime, the way the prototype is. And then the third big change is, can an object change its superclass at runtime? And again, the answer for prototype instance is yes, and the answer for class instance is no. So it's a simple matter to change your prototype in the prototype instance model. You simply set that prototype property to point to a different object. but you can't change your superclass in the class instance model. It's set for all time. Once you create an instance of it, you're done. You can't change your prototype. Yes?
Like a third object D that also referenced C as a superclass. You say prototype equals new C. Does it get the same?
No. Good question. So the question was, if I have b.prototype or b1.prototype equals new C, and I say d.prototype equals new C, they get different prototypes. But I can easily get around that. I could say a square prototype. Let's say C is a square. I could say square prototype equals new C. And then I could simply set b1.prototype to square. So if you really want that, and often you do, then you just create one instance of C, make that be the prototype that you assign to all instances. So that's the way you do it. So you do have to be careful though, because if you're not, you'll end up with a different prototype for each instance. Probably not what you want. Okay. Other questions? So these are the three big differences. And the reason that scripting languages adopt prototype instance is because it's good for prototyping. You're able to quickly, for example, in a graphical user interface, I just said square prototype equals new C. Let's say I wanted to see what something looks like as a set of squares and then as a set of circles. I could also have a circle prototype. And maybe that is equal to new circle. And then by setting all of my instances, prototypes from square prototype to circle prototype, I could make them all change to circles on the screen while the program's running. So I could be sitting with a customer and saying, do you like A or B? And by simply changing the inheritance hierarchy, I could actually change the shapes that appear on the screen. That's a real handy feature in a graphical user interface. So that's good for rapid prototyping. And the same is essentially true for being able to dynamically add or delete instance variables. It just turns out it gives you a lot of extra flexibility where you can customize each instance object. In some instance objects, you may want to override the default properties in a prototype by defining new values for them. So for example, I might actually, let's go back here, I might have said in C this dot width equals 40. Now in B, I'm choosing to override the width. So what I am able to do with a prototype instance model is selectively override certain variables with new values. And then if I no longer want those values, I simply delete the property and it again re-inherits from the prototype. And you can't do that in the class instance model. Class instance model, you're not inheriting any values from the class. The constructor will give you perhaps default values that perhaps you share with other objects, but you can't enforce the fact that all of your instance objects share the same inherited value. But in a prototype instance model, you can, because you have always these values sitting there in the prototype, and as long as you don't define similar properties in the instances, all those instances will share the same values for that property. And then you can quickly change that value. So in a class instance model, let's say you want it to, the customer says, oh, the width isn't wide enough. Let's see what 20 pixels look like. Well, here you would just say square prototype dot width equals 20, and immediately that change is propagated to all instances of the square prototype, and all the widths change to 20. You can't do that in the class instance model. You'd have to find every instance that you'd created, which you'll manually have to keep track of. So you have to keep a list of every instance you created, and then you'd have to go through that entire list and set all the widths to 20. It's a lot more error prone. And if you deleted an instance, you'd have to remember to delete it, the pointer to it, from that list, or you'd have a dangling pointer. So it's a lot easier in a prototype instance model, again, to quickly change values of properties and have that change propagate immediately to all instances of the prototype. Again, those instances or changes immediately show up in the graphical user interface. And JavaScript is exactly that. It's working with a graphical interface in your browser. Yes?
If the subclass basically that you have, if you try to delete a property from it that it doesn't have, but its superclass has, it won't delete it from superclass, will it?
No. That's right. So if it does, the question was basically if you try to delete the width property from an instance and that width property doesn't exist in the instance, it just has no effect, or you might get a runtime error. I'm not sure which. Okay, so that's why scripting languages use a prototype instance model, because it facilitates rapid prototyping. That's what scripting languages are all about, is rapid prototyping. So you might say, okay, since it's so powerful and flexible, why not have compiled languages also adopted a prototype instance model? And the reason is it's very inefficient from a computational point of view. So if you're able to add or delete instance variables, the best way to handle that is with a hash table, which is not as efficient as if you can simply allocate a fixed struct, which is what a class instance model does. With a class instance model, for example, with a square, it's just going to assign for each instance, you will have the width and the height fields at fixed offsets. So you can always quickly get to the appropriate field using an appropriate offset, and that offset is set by the compiler at compile time. So it's a lot more efficient. You're not doing a hash on the property name. Instead, at compile time, you know exactly where that property or field is located in the instance object. It's just an offset. It's a static offset, and it's the same for all objects. So by prohibiting you from adding or deleting instance variables from the instances, with a compiled language, you get the advantage of fast access, a static structure, fixed offsets to each field. That's very fast access. So that's the trade-off that we're working with, is that in a scripting language, we're trying to optimize the programmer's time. So we're willing to be flexible and trade computational efficiency for programmer efficiency. We're not willing to make that exchange in a compiled language. In a compiled language, we inconvenience the programmer in the interest of computational efficiency. Therefore, compiled languages go with a class instance model. Okay, so questions about that? This is a just perfect grist for final exam questions, plus quiz questions. Okay. So I think it's a pretty natural model. In fact, during my postdoc, prototype instance models were just coming out, and we were one of the first groups to experiment with them. There was a group at Sun that also was experimenting with them, both in the context of graphical user interfaces. So I'd like to think that actually some of the work that my postdoc advisor and I did while I was a postdoc eventually found its way into scripting languages. Okay, so that finishes up objects and brings us to the second topic for today, which is how we can go about interacting with the graphical interface, how JavaScript can modify a page in the browser. So today we're talking about the output side, and on Thursday we're going to talk about the input side. So today we're going to talk about how you can write things and modify a page by writing to it. On Thursday we're going to talk more about how you can interact with form or with elements of a page using JavaScript, using various events. So again, the basic idea is that every web page is organized into something called a DOM, or Document Object Model. So you saw that with XML because XML has a DOM parser. It's the same idea. Just like XML, an XML document can be parsed into a tree, HTML is also a markup language, and therefore every HTML page can be parsed into a tree based on its tags. So the internal nodes are the tags, and the leaf values are the content of the tags. And that's called a Document Object Model, or DOM. You'll hear me call it DOM for the most part. So every web page has this DOM object associated with it. And as I just said, each markup element is a node. It's actually an interior node in the tree. And the leaf, so-called leaf nodes, contain the text content or the image content or whatever of that node. So the leaf nodes contain content. The markup content. So the interior nodes, the interior nodes is an interior node. Okay? So you've got this DOM. It's automatically created for you by the browser. And the first question should be, well, how do I access it? The document keyword. All versions, all browsers, this is just defined in JavaScript. Document is your pointer to that DOM object. And obviously it's going to have a lot of properties and methods that you can use to manipulate it. And the way that you're going to be able to alter your web page is by, you can change leaf nodes. So if you change a leaf node, then that's going to alter the content of the page. If you modify interior nodes, that's going to more broadly change the structure of the page. You can create new content by creating a new subtree and adding it to the DOM. You can delete content by deleting a subtree from the DOM object, and you can change structure by replacing one subtree with another subtree. Then on top of that, we're going to see that every object, every node has style attributes that control things like the font size, the font face, the color. So you can change the style attributes of each node, and that's going to also affect the appearance of your page. Okay? So the first thing that you need to know is I need to get access to certain nodes. Okay? It's important if you want to change the color of a paragraph, or if you want to get to a certain form element to disable or enable it, you need to be able to get a pointer to that node. And there's essentially 4 methods provided that by the DOM that you can do it. The most important is the first one you see here, get element by ID. So you're allowed, when you create a tag, to include a ID attribute. When you include an ID attribute, you can access that node by saying get element by ID and substituting in this case it would be BVZ. If a node with that ID exists, it will return a pointer to it. And if it doesn't, I think it returns null. You obviously should not have identical IDs in your HTML document. I'll be honest, since I've never done that, I'm not sure what happens if you have identical ID values in your document. But obviously you want to avoid it because it creates ambiguity. So the ID attribute is supposed to be unique. Okay, the second way you can get things is by class name. So you're also allowed to have class attribute. And that's not necessarily unique. So this might be class equals intro. So sometimes you want the intro paragraph in a section to be have slightly different style than the remaining attributes. For example, you might want the first word bold-faced, or you might want the first word indented. So in that case, HTML has this class keyword, and cascading style sheets use the class to allow you to style all tags with that class in the same way. But sometimes you also will use class to identify similar things like multiple choice questions in a quiz. You might say that I want all multiple choice questions, then you would say class equals multiple choice for those questions, and then you can get a list by saying document.getElements by class name. So unlike ID, class is not unique. You in fact expect there to be multiple instances of that class. So you're getting a list. So that's the second way. The third way is that there are certain predefined lists. One is the forms. So if, and actually I should say they're associative arrays. So one predefined property is forms. Every form, remember, has a name, and you can get at that, a pointer to that form by giving it the name of the form. So in this case, the name of the form is reservation. So that's by the HTML form name, which is, remember, name is an attribute. So that's how you can get access to forms. Okay? It turns out that there's a number of other named arrays. So you can get access to all your anchors, which are the A tags, through another table. You can get access to all of your images, which sometimes you want to do because for animation purposes, through the images table. And this last one you don't really want to worry about. It's kind of abstruse. It's not, you think when you see it that that must be the A tags. It's not. It's something about files that are imported in the head block. You almost never are going to use that. So this third technique here is access through predefined associative arrays. You can get at forms, images, anchors that way. And then sometimes you want access via tag names. So you might say, what's the difference between a class and a tag name? Generally, a class, usually a class is a subset, a proper subset of a tag. So you may have several different types of classes within your tag. For example, a paragraph may have introductory paragraphs, concluding paragraphs, and then middle paragraphs. So it might have 3 classes. Okay, so typically a class is a proper subset. The objects in a class are a proper subset of the objects in a tag. So you can get all elements by tag name, and that will give them to you in some order. I think it uses a pre-order search, but I'm not 100% certain about that. And whenever you get a list back, so get elements by class name will give you a list back as well. You can simply iterate through it, and it has a length, and you can access it as though it were an array. Okay, so you can access that list. And then this inner HTML is a way to get at the text content. Gives you the text content of a node. So it's inner and then HTML all capitalized. I believe at some point the W3 consortium formalized this property. It used to be an informal property that was supported by all major browsers, but it wasn't in the standard. I think that changed a few years ago, but I'm not 100% certain. It's not really, it's kind of just unimportant because every major browser supports it. Okay, so those are the 4 main ways you gain access to or pointers to nodes in the tree. So now you have the pointer and you want to modify your document. Okay, so there's the very primitive and unrecommended way of doing it, which is to use the write method for the document. The only time you should use the write method is when the HTML page is being loaded for the first time and you're creating some dynamic content. Because the write method destroys whatever is previously on the HTML page, meaning it literally wipes out the pre-existing DOM object and creates a new one. So you really don't want to be wiping out. The whole point of JavaScript is to do surgical changes to the page, not wholesale wiping out of the page. So you only really use the write method when you're creating or loading a new HTML page. It's a little like a PHP embedded code island in that case. You're simply creating some dynamic content as you load the page. So the write command is good for creating dynamic content, when the page is loaded. Okay, but thereafter you have other tools at your disposal. Okay, and the primary tool for modifying content is actually the inner HTML. So if you get a pointer to the node you want to change and you modify the inner HTML property, then it will change the web page. Okay, so it's fun to kind of experiment. I'll go to the W3 Schools, which has a nice try it out thing. So let's go down to their DOM. Let's see, DOM HTML. There we go. So let's see. So originally, let's take this script out of here. Actually, let's just comment it out. You can't. Let's comment out this. So if I just run it here, you see that it's hello world. Okay, because that's what this element right here is. Okay. But I can change the content dynamically using this script. So what this script is doing is it's getting the paragraph that's identified by the ID P1. So now I have a pointer to this tag. Then I set the inner HTML to be new text. And you can see now if I run it, what appeared on the screen was new text. Now usually this would be done in response to interaction by the user. This is kind of silly to do this and then just change it this way. But I haven't yet showed you how the user can interact to change it. Okay, actually I could. Let's do very quickly. Let's call this a function, change wording. And I'll say here on click. So it turns out on click is a event, and we're going to call change wording. So here it's not going to actually execute until I've actually clicked on this particular tag. So again, I'll run it, and now if I click, it changes to new text. So it's going to, this is for Thursday, so don't worry a whole lot about it now. But JavaScript, or actually HTML, has a variety of events that you can attach code to. And when those events occur, the code executes. And as you saw, in this case on the click, it executed change wording, and that changed the content from hello world to new text. So in fact, on Thursday, we'll learn that the key to doing this modification with JavaScript is with events. Okay, so the changing the inner HTML is nice for changing text content. Okay, but let's say you have something like an image, and an image is not a text, it actually is determined by the source attribute. So if I want to change an image, like to do animation, you know, an animation is often just a series of what are called sprites, which are just images that are quickly swapped. Then you change the source attribute. So here we get the element whose ID is image, and we change its source attribute to be landscape.jpg, and now it is going to be, they'll load this particular JPEG, and you'll see that new JPEG appear. So that's how you do animation. Okay? Sometimes you want to change color, or you want to enable or disable a form element. There is a style object. So with every node, there is a style object. And that is created by the CSS, the cascading style sheet. So this cascading style sheet sets up this style object, and then you can modify it by selecting the right attribute and setting it to an appropriate value. So here, I'm setting the color of the P2 element to blue. Okay, we can see it over here in the Triad editor. I will, instead of setting it to new text, I will say style.color equals blue. So now when I click on it, it changed to blue. So that's the third major way that you can change things, is you change one of those style attributes. And you can go online and look all of these up because there are many, many style attributes. Here, one thing you often do in forms is you enable and disable form elements. So for example, someone may have beneficiary information, but only if they check the box, and once they check the box, you want a whole bunch of things enabled. So in this case, you are getting the beneficiary box setting its disabled attribute to false, which paradoxically enables it. Okay, so those are the three major ways of modifying content, existing content. Change the inner HTML, change an attribute that's important like the source. Now this is what hackers do. What do you think which attributes do you think they go about changing? The href attribute for an anchor to direct you to a web page that you don't expect. So that's something that hackers love to do, is to change the href attribute for an anchor to a new URL. And then finally the style attribute, which changes the appearance. Now, that changes existing content. So I said changing HTML elements, this changes existing content. But the other thing you might want to do is you might want to add or delete content. So you want to make more sweeping changes to your document. And the way you do that is by actually modifying the DOM tree. So you're going to add a new subtree to add new content, delete a subtree to delete content, or replace one subtree with another subtree to change significant content. So if you want to create a new element, there is a method called createElement, and when you give it the tag name, it's an HTML tag like P or H1 or HR, it will create a new tag element for you, object. And then you can do different things, like here, once I had new paragraph, I could now say new paragraph dot inner HTML, and then whatever I wanted my content to be. Okay, but that's not enough. Just because you have created an object, you actually have not yet added it to the tree. In order to display that content, you need to get that new object added to the tree in the right place. And there's a number of things you can do. So you could insert it before some element in the tree by choosing the parent. So first of all, you would have to get the parent node. So you'd have, here's the parent. It has some siblings, maybe S1, S2, S3, S4. So you could insert before any of those four siblings by giving that sibling node as the target. And again, you would have to have a pointer to it. So this target would have to be, this is a pointer to sibling. It can't be the ID. It actually has to be a pointer that you've gotten using getElementById. Same thing for parent. Parent needs to be a pointer. So that works fine if you want to insert it before one of the siblings, but what if you want your new element to go at the end? That doesn't work so well because you can't insert it before anything. So for that, you get append. If you want it to go at the very end, you call append child. That puts it at the very end. So that covers all possible slots that you might want to put it under a parent. Or you might want to replace one child with your new child. So in that case, you give the old child and the new child, and the new child will replace the old child. That's replacement of content. Okay, and finally, you can remove, if you have a pointer to a subtree, then remove child will remove that subtree from the page. Okay, so we can have fun with that. let's do that. So let's have change wording. Instead, let's have change wording add some stuff. So we will say var new para equals document dot create element p. We'll set new para dot inner HTML to be hi Brad. And now we have to add it. So we need a pointer. Let's see. Have to get the body in this case. Let me figure out what that is. So the issue I'm having is, what is the parent? Okay, so P1 has a parent. The question is, what is P1's parent? Actually, I can get at it. By, I believe, the parent attribute. If we go down a little bit, there we go. Everyone has a parent node, so we will say document.getElement by ID P1. Call that P1 equals. Then we'll say P1, we'll say parent equals P1 dot parent node. And finally, parent dot append child new para. And we'll hope this works. And it did. It added hi Brad at the very end. Okay. Now it didn't go after P1 because this paragraph was also here and I used append child. If instead I had said insert before P1 new para, then it would have gone before P1. Now, why is it bad not to put vars here? Why should I forgot to put vars here? Why is it bad that I didn't put vars there? You need to know this. Vars make it local. Without it, it puts P1 and parent into the global namespace for the page. That's bad. So you need to remember to put vars before local variables in your functions, which I have a bad habit of forgetting to do. And it usually comes back to bite me. Okay, so you can see how it was changing content there based on different things that I was doing. By the way, this try it editor is really nice for trying stuff out because it gives you a little sandbox to play in. I used to try to use it in class, but when we do that, W3 Schools thinks it's getting a denial of service attack from UT, and it locks us all out. So I no longer try to do it. Okay, so we will get more into things on Thursday with this, but just a preview of how you change things is that all elements have so-called events that you can, and event properties, and you can associate code with those events. And by assigning either code or functions to those events, you can force those functions or code to execute when the event occurs, and that will change the document in the way that you would hope. And I already illustrated that a few minutes ago, so I'm going to move on. As I said, we'll get more into this on Thursday, where we go through the different types of events that HTML gives you. So then it's important, there's other ways you can navigate the document object model. As you just saw, I used the parent node for P1 to get at its parent. But there's a whole bunch of things. So a parent has this thing called child nodes. So that's a list of all of its children. You can also easily get access to the first child, which is just child node 0. So just putting this here, this is really child nodes 0. This is really just child nodes of child nodes length minus 1. So it's just handy names for them. Next sibling, as you might imagine in previous sibling, gives you pointers to your next and previous siblings. So for example, going back here, if I wanted to insert hi Brad between hello world and the paragraph was changed by a script, I could have said insert before p1.next sibling. And now p1's next sibling is this paragraph. So when we run it, it should show up between hello world and the paragraph above, and sure enough it did. So next and previous siblings are nice. Then I was having trouble getting access to the parent. I believe that document.body would have also done the trick for me. We can try it out. So let's just say, instead of all this, for a moment, let's try to just say document.body.appendChild, new para. I bet it will work fine. Indeed it did. So that was yet one more way to get access to the parent of P1, was through this body attribute. And then if you want access to the root of the entire document, which typically you don't need access to it, but if you did, then document.documentElement gives you access to the root of the document. Remember, document is just giving you, is encapsulating. So document is a pointer to this entire thing. Part of it is a tree. Okay, then document.documentElement, that's gives you the actual pointer. The document is a container object. Document element is actually the root of the tree. So then head and body, then P1 was down there. Okay. So something that you will see in old code, because inner HTML didn't always used to exist. So you will sometimes see, instead of node.innerHTML, you will see this kind of code, node.firstChild.nodeValue. So every node, technically, if it's like a P, then its leaf is a text node. And the way you get to that, it has one leaf, and you get to it by first child, and then you change the value of the node by changing the node value attribute. I don't recommend you use this anymore, but this is how it used to be done before inner HTML existed. So you might see code that looks like that, and you might also, great. I took it out. I will have to figure out. There's ways to create. So the way I suggest doing things is creating this inner HTML. There is a way to create a node. So this automatically creates the text node for the para object, but there's also a way, and that's what I'm forgetting, but essentially there's another way that it's roughly like this. Text node equals new node, something like text node dot node value equals hi Brad, and then para dot append child text node. The only thing I'm uncertain here is this. This is the only, in that code, that's the only thing I'm uncertain of. I forget what that class is, but that's old style. And it takes 3 lines to accomplish what .innerHTML accomplishes with 1 line. But again, you might see that in older JavaScript code, and that's the reason you see it, is it was written before innerHTML either was available or because the programmer wanted to ensure that every browser would support it and therefore wasn't taking any chances. So that's the other way you could add new text content to a tag. So questions about any of this? Okay, so today this pretty much covers what we've covered is the prototype instance model versus class instance model, and then we moved on and talked about this HTML document object model, the methods it gives you for navigating the DOM, methods it gives you for changing existing content, and methods it gives you for adding or subtracting content. And Thursday, we're going to go to the input side and talk about how you can define events that should respond to the user, so that you can actually have a way of modifying the text page. Okay, so we'll take that up on Thursday. And we are done.